talking mathematics of finance. So in the business, as the saying goes, time is money. We must pay interest for the use of our property or money over time. When we borrow money, we pay interest. When we loan money, we receive interest. When we invest money in a savings account, we're actually lending money to the bank. So, suppose a principal of P dollars is invested in an account bearing an interest rate R expressed in decimal form and calculated at the end of each year. If A sub n represents the total amount in the account at the end of n years, then the value of the investment follows a growth pattern shown in the table. Now, time 0 is your initial principal, your initial amount, which is your principal. At the end of 1 year, A sub 1, we'll have your principal plus the principal times the interest rate. We can factor out a P, so we can factor out your principal, you're left with 1 plus R. Now at the end of 2 years, we'll take our principal times the 1 plus R, so what we had at the end of the first year, multiply that by 1 plus R again, same idea as here, so we have the principal times 1 plus the rate squared. You do that enough times, you'll get A sub n, which is your principal times 1 plus R to the n power. Does that look like anything we've talked about before? That's what our exponential growth was. That's our exponential growth. We call interest computed in this way compound interest because the interest becomes part of the investment, so that interest is earned on the interest itself. All of the accounts, all savings accounts, things like that, they're computed that way. All right? Now, if a principal P is invested at a fixed annual interest rate R, calculated at the end of each year, then the value of the investment after n years is A equals the principal times 1 plus R to the n power, where R is expressed as a decimal. It's actually super easy, and we shouldn't have much trouble with this at all. Now, find the amount A accumulated after investing in principal P for T years at interest rate R compounded annually. So, our A will equal 500, 1 plus 0.05 to the 10th power. What this will be then, when we put this in our calculator, 500 times 1.05 to the 10th power. $814.45. Now, why don't you all try B? All right, when we do this here, what we have, our A value will equal 1,500 times 1 plus 0.07 to the 6th power. $2,251.10. Are there any questions right now? Awesome.
Wait, did you round up?
Yes. Sure, I'll go back. You know, you have a calculator that actually figures this stuff out too. All right. Now, interest compounded K times a year. In the previous example, we only compounded interest once a year. Suppose the principal P is invested in annual interest rate R compounded K times a year for T years. Then R divided by K is the interest rate for a compounding period. Think about this. If you're getting 7% interest compounded 4 times a year, the way they figure that out, they take the 7% divided by 4. So they take the 0.07 divided by 4. How many compounding periods for the life of the investment? Well, if you're compounding 4 times a year for 7 years, how many times do you compound it? 28 times. Does that make sense? So that's really what's going on here. So this is going to be our formula. So we basically take the same formula we had, but instead of r divided by 1, because you're compounding once a year, it's r divided by k, and then k times t for the power. Now, so find the accumulated amount. A will equal 500. 1 plus 0.09. It's compounded 12 times per year. 3 times 12. This section, yes, I would give you all those, but this section will not be on the test on Friday. No, Bishop. No, I wouldn't give you this. I'd give you all these. Yeah. In order to complete the problem, that's what you need. Right. All right, so if we figure this out, 500 times, or actually we'll use parentheses there, 1 plus 0.09 divided by 12, carry that to the 36th power, and you get $654.32. Please do these. Through this now. What we'd have, A will equal 1,500. 1 plus 0.07 divided by 4 to the 20th power, because 5 times 4 is 20. $2,122.17. Are there any questions on this right now? All right, now the problems in examples 1 and 2 require that we calculate A. So basically just put the numbers into the formula and get out an A. Examples 3 and 4 illustrate situations that require us to determine the values of the other variables in the compound interest formula. So in example 3, Judy has $500 to invest at 9% annual interest, compounded monthly. How long will it take for her investment to grow to $3,000? So, $3,000 equals 500, 1 plus 0.09 compounded monthly would be 12. We make this 12t. Okay? Now, what we would do to solve this, we could put it in our grapher. 3,000, then 500, 1 plus 0.09 divided by 12, take that to the 12t power. Put that equation into your calculator. Put that into your calculator. Hey. All right, and this would be a good window to use, 0 to 25 and 0 to 4,000. So there's our 3,000. We want to find, basically, find our intersection here. So about 19.98 years. T will equal Now let's do this algebraically because we can do this algebraically. How would I start to solve this algebraically? Divide by 500. What's 3,000 divided by 500? 6. Now we need to figure out 1 plus 0.09 divided by 12. 1.0075 to the 12t power. If you have a question, that's fine. 3,000 divided by 500. Now, what we want to do, take the natural log of both sides. When you do that, what happens to this? What happens to the power 12t? It'll go to the front. So if ln of 6 equals 12t times ln of 1.0075, how do I get 12t by itself? Divide by the natural log there. So I'd find this, ln of 6 divided by ln of 1.0075. Divide that by 12, and you get your t of 19.98. Okay. Now, why don't you guys try B? Then we'll go over it. Yes, what's your question, Saito?
Do you divide those and then what do you do?
Oh, for this? Or from the blue?
Yeah.
I figured this out. I divided by 12.
Okay.
Now we do this if Joelle invests $8,000 into a retirement account with 11% interest rate compounded monthly. How long will it take until this single payment has grown in her account to $16,000? So we have $16,000 equals $8,000. 1 plus 0.11 divided by 12 to the 12t. So it's pretty much the same type of problem. We'd have 2 is equal to 1 plus 0.11 divided by 12. 1.0092 to the 12t. Take the natural log of both sides and then divide.
Yeah.
Okay, now I know I realized I combined some steps there. I took the natural log of both sides, moved the 12t, and divided all kind of in the same step in my head. Yes, Stephanie?
Okay, so at our test, we have the steps for this. Are you going to tell us that we have to do that very quickly?
I will tell you have to do it algebraic. Sorry.
Our example for this we have our test.
Sure. Not on this current one, but no.
Oh.
Yeah. What, this test on Friday, what are the sections?
I've told you that 3 times.
I haven't heard one.
I didn't get that. I got 6 questions for 3.
Oh, it's right because I used the wrong finger. That's why. So it should be 6.31 years. Now, a couple things before we move on. If you would have used this, ln of 2 divided by ln of 1.009 divided by 12, you would have got 6.45 years. Okay, so 6.45 years is fine. If you really, truly want to get the exact answer, the correct answer, exact, would be 6.33 years. That'd be the most exact answer you could get. Okay, 6.33. Now, finding interest rates. Stephen has $500 to invest. What annual interest rate compounded quarterly, so 4 times a year, is required to double his money in 10 years? Well, how much is double 500?
1,000.
Okay, so I'm just, instead of having something for t, we got to find t. We put a value in for t, we are looking for r. 1,000 is double 500. All right, so I'm going to divide by 500, so I'm going to have 2 is equal to 1 plus r over 4 to the 40th power. Now, in order to get 1 plus r over 4 by itself, what root do I have to take? I have to take the 40th root. So I'm going to take the 40th root of 2 is equal to 1 plus r over 4. How do I get r over 4 by itself then? Not yet. I got to subtract 1 first, then multiply by 4. Okay, so we could say 4 parentheses, 40th root. Press the math button to get number 5 of 2 minus 1. Should get us at 0.0699. What would that be as a percent? 6.99%, right? There we have it. Now, another way we could have done this in our calculator, we could have taken 2 to the 1/40th power, subtracted 1, multiplied by 4, and you'd get the same thing. Okay, so if you don't feel comfortable putting it all in one thing, do it separate. It's more important that you get the correct answer than trying to do it very quickly in one method. Does that make sense? Please try B. All right, what interest rate compounded daily is required for a $22,000 investment to grow to 36.5 in 5 years? So I have 36.5 equals 22,000. 1 plus r over 365 to the 5 times 365. So what we want to do here, you want to take 36,500 divided by 22,000, and you get this crazy decimal, right? Now, I would suggest pressing math, enter, enter. That will put it into a fraction of 73 over 44. All right. Now, in order to solve this, we would take the 1825th root of this answer. So 1825 math, number 5 of our answer. So if you just do it like that, that's fine. Or if you want to do 73 over 44, remember you got to put 73 divided by 44 in parentheses. So you get this number here. We would subtract a 1 and get this, multiply by 365, and you get 0.1013. Which would be about 10.13%. Are there any questions at this time? Now, interest compounded continuously. In exploration one, $1,000 invested for 1 year at a rate of 10% interest. We investigate the value of the investment at the end of 1 year as the number of compounding periods K increases. In other words, we determine the limiting value of the expression 1,000 times 1 plus 0.1 divided by K to the K power as K assumes larger and larger integer values. Okay? So here's what we're going to have. Let A equal 1,000 times 1 plus 0.1 divided by K to the K power. Complete a table of values of A for K equals 10, 20, 100. All the way up to 100, what pattern do you observe? So I'll help you do the first few. Okay, so 1,000 times 1 plus 0.1 divided by 10. Raise that to the 10th power. And you get 1104.62. Now, to figure out the 20th one, instead of putting that whole thing in again, I would press second enter, and that recalls the last thing that you put into your calculator. Change a 10 to a 20 for both parts. 1104.90. Now, I'd like you guys to figure out 30 through 100. So, the numbers that you should have: 104 or 1104, 99, 1105.03. 1105.06, 1105.08, 1105.09, 1105.10, 1105.11, and 1105.12. Now, what I'd like you to do, after you figure out this chart, I'd like you to put this into Y1. Please put this into Y2. Just X is fine. Yep. Now, because it says here, the graph shows the graphs of the function a of k equals 1,000 times 1 plus 0.1 to the k, or 1.1 divided by k to the k power, and the horizontal line y equals 1,000 e to the 0.1. This is a constant number. That's why it's a horizontal line. 1,000 e to the 0.1. E is a number. Okay, 1,000 times that number. Now, the window that I would use, I would go 0 to 50, go up by tens, and I go 1,100 to 1107, and go up by ones. If you graph that, you get something that should look like this. Now, this top line here, I'll take a picture of it. Now, this is Y2. This one is Y1. So what does that tell you about Y2? It's a constant. Does it look like something that we've been covering lately? Kind of looks like an asymptote, doesn't it? Okay. So that tells you then that this is a horizontal asymptote of a of k. All right. So the top that it's going to be as big as K gets, it's going to eventually level off to about 1105 and some change. Okay, as you can see, it's starting to level off here. Now, recall from section 3.1 that the number e is going to be the limit of 1 plus 1 over x to the x power as x gets closer to infinity. Therefore, for a fixed interest rate r, if we let x equal k divided by r, so 1 divided by k divided by r, we'll end up getting the limit of 1 plus r over k to the k over r power as k approaches infinity. That is also going to equal e. But, however, we don't know enough about limits, but with some calculus it can be proved that that limit will equal the principal times e to the RT power. So A equals P e to the RT power is the formula that's going to be used when interest is compounded continuously. Now, in nearly any situation, one of the following two formulas can be used to compute compound interest. Now, before, I told you that there were really two formulas that we're going to be paying attention to. One, when its interest is compounded so many times per year, and one where it's compounded continuously. The question on a test or a quiz or even your homework will tell you if it's compounded continuously or compounded so many times per year. So you just have to pay attention to the wording. Now, if we look at example 5, suppose you invest $100 at 8% annual interest, compounded continuously. Find the value of your investment at the end of 4 years. Okay? So we're going to use A is equal to P times e to the RT power. So A will equal 100 e to the 0.08 to the 4th power, or times 4. So in your calculator, 100 e to the 0.08 times 4. 137.71, so $137.71. Now, if we look at B, actually, yeah, we'll look at B quick. Suppose you invest $1,250 at 5.1% annual interest compounded continuously. Find the value after 10 years. So A will equal 1,250 e to the 0.051 times 10 power. $2,081.61. Now, I want you to think about this. What if it wasn't exponential? What if it wasn't compounded continuously? Let's say it was compounded daily. Let's find the same thing compounded daily. So it would be 1,250, 1 plus 0.051 divided by what? Divide that by what? 365 is daily. I'm going to take it times 10 to 365th power, right? So 1,250 times 1 plus 0.051 divided by 365. Carry that to the 3650 power. 2,081.54. So, how much of a difference is it if it's compounded continuously or compounded daily? 7 cents. So, is it really worth your time to find a bank or an investment that compounds continuously? They're very few and far between. A lot of the banks that you find will always compound daily or monthly or weekly, that sort of thing. So you won't find too many banks that actually compound continuously, but we do have that formula. Okay? Are there any questions over any of the examples we did today?